Right, so what we'll do now is have a look at one that is a little bit more complicated in terms of the fact that it includes some two components on a secondary side for a start, and we've got a mixture of inductance, capacitance and resistance, and therefore we have to consider that the values are complex in nature. Okay, so turns ratio of 1 to 50, so right up front I is 1/50, which is equal to 0.02. Yeah. It's quite handy. I've given you the capacitor and inductor values as impedances rather than inductance and capacitance, so we haven't got no calculating of reactances. I've given you the values in ohms. But what must you remember about those two values? What have we got to add to the 30 kiloohms for the capacitor, and what have we got to add to the 5 ohms for the inductor? Yeah, or in polar terms, you've got to add what angle for capacitor? Minus 90 degrees. Inductor plus 90 degrees. Yeah? Okay. Or in J terms, this is a negative J term, positive J term. Right? So we've got to shift these two impedances one at a time. Okay? So 5 minutes for the values of ZR dash and ZC dash. So that is our simplified diagram by transferring the two secondary impedances across to the primary side. Because we've got a mixture of inductance, resistance and capacitance, we need to deal with complex values. So next step, total impedance. How do we calculate it for 3 series components? Add them up. So we've got ZL plus ZR dash plus ZC dash. Right, without a calculator, Danny, what's the rectangular value for the inductor? Think about your axis. That way is 0 degrees, that way is 90. We're 5 in the 90 direction. How many in the real direction? 0. So it's actually ZL, sorry, is 0 plus 5J. Yep. ZR is all resistance, 16 plus no J. ZC, 0 minus 12J. And they're all ohms. Now we can add them up, can't we? 16 minus 7J. Convert back. I get ZT is equal to 17.5 ohms, angle minus 23.6 degrees. Just check, because I could have got it wrong. Wasn't possible to find. Now we know the total impedance connected to the generator. Yep, we can find I1, which is equal to, say it now, I2 over A, because that's what we're really interested in, what the secondary current is. Right, probably neater to write it as I2 dash at this stage. That's equal to EG over ZT. Generator voltage is 80 volts. No angle given, so we always assume that must be 0. Over 17.5. Angle minus 23.6 degrees equals now I've got 4.57 amps, angle 23.6 degrees. Yeah. We've got a little check here. We've got a capacitive element there that is bigger overall than the inductive element, so that's going to be capacitive in nature. CIVIL, currents leading the voltage, capacitance, current leads voltage. Check. Happy now? I've checked. That makes sense for the theory. You see what I'll tend to do all along. Does that make sense to me? Should I have a current that is leading the voltage? Because that's what that positive angle says. Yeah. Now I know the current, what else can I find? Bearing in mind always what I'm interested in finding in the first place, which is the current in the secondary. So I'm on my way to finding that because I've found I2 dash. Yeah. What else do I want to find in this side? So I can find where I want to know the voltage across the resistor in the secondary. So I find ER dash. How can I find that? Using Ohm's law. Yeah, the current I want is I2 dash times R dash or ZR dash. That is 4.57 angle 23.6 multiplied by 16, wasn't it, the resistor? 16 angle 0. I made that 73.1 volts angle 23.6 degrees. Yeah. And you can check it, right? But I made that oh, I don't know what that was in rectangular now. Just jot them down here. Oh, which work that one out in rectangular for us. Yeah, this value here. 66.9. So plus about 29J. Yeah. You know where I'm going with that. That was my check yesterday that helped me find out that I'd made a mistake. And I'll tell you where I made the mistake in a minute. Okay. So that's ER dash. Yeah. Then I could find BC dash, which is I2 dash times ZC dash 4.57 angle 23.6 degrees times, and this is where I went wrong initially. I went 16 angle 90 minus 90 instead of 12 angle minus 90. Easy mistake to make when you've got particular numbers in. And my check at the end, adding all of these voltages up to see whether they added up to the supply voltage, didn't work out. So I knew I'd gone wrong somewhere. The answer to that is 54.8 volts angle minus 66.4 degrees. And in rectangular, that work out to we don't need it, but for the purpose of the check, I also calculated EL, which is I2 dash times ZL. That's the 4.57 angle 23.6 degrees times 5 angle 90 degrees. Just work that one out. 4.57 times 5 is 22.9 volts angle 114 degrees. And in rectangular that is plus 21J. Yep. Now, my check is to add all these three values up equal the voltage we started with in the first place, 80 angle 0. So if you add up them J terms, do they equal 0? And if you add those together, do they equal 80, there or thereabouts? And my check yesterday initially didn't work out like that. So I had to go back through and find out where I'd gone wrong. And like I said, that was in this EC one, I put 16 in there instead of 12. Yeah. So that definitely, it don't matter how experienced you are, it's easy to write something down wrong. So anywhere where you can just check back or does it make sense is useful. Okay. Now the values we're interested in is that one and that one and the current, because we want to know what they are on the other side, don't we? So going back down here, final answer, we know that I2 dash is equal to I2 over A, therefore I2 is equal to A, I2 dash equals A times 4.57 angle 23.6 degrees. A is only a ratio, so it ain't got no angle associated with it. That's 0.02 times 4.57 angle 23.6 equals and I got 91.4 milliamps and the angle is 23.6 degrees. The transformer don't do anything to the angles, doesn't shift the phase at all. The ideal transformer doesn't. So that's that one. E2 dash is equal to A times E2, therefore E2 is E2 dash divided by A, oh, hang on, let's go, so we want ER really, don't we? ER over A. ER was 73.1 angle 23.6 degrees over 0.02. I got that as 3655 volts angle 23.6 degrees. Angle of current and angle of voltage for a resistor are always the same. Something else that is a good check that you've got things right. And then EC dash is equal to A times EC, therefore EC is EC dash over A, that's 54.8 volts, angle minus 66.4 degrees over 0.02, and for me that came out to 2740 volts, angle minus 66.4 degrees. Okay.